All right, for this one, we can see that the two equations are not in the same format, so we need them to be in the same format, right? So we're going to force them to become the same format. So the first equation there, we can see that it has the x term, then the y term. Right, there's the 2x, there's the y, there's the number. The other one has the y term equals the number and then the x term. We can't have that. They need to be in the same format. So I'm going to change the bottom one into the bottom equation into the format for the top one. So I'm just going to add 6x's to both sides. Of course, I'm not going to combine the 3y with the 6x. I'm going to keep them separated, which would give me 6x plus 3y equals negative 17. So I didn't line up the equal signs exactly with that line that came down, but it still works. So we're going to look at the other equation as well. I should probably just rewrite it. So that was 2x plus y equals negative 6. And from here we need to do some analysis, right? What coefficient can we make opposites and make them pretty quick? As it turns out, both y's and x's would work. For this one, though, I'm going to force the coefficient of x there to be a negative 6. Now, I want it to be negative because the 6x above it is positive. So I'm gonna multiply this by negative 3. So again, the 2 multiplied by negative 3 is going to be negative 6. They'll be opposites, and they should eliminate, right? So let's go ahead and distribute that negative 3 into the full equation. It has to distribute it to all the terms. So negative 3 times 2x would be negative 6x. Negative 3 times 1y would be negative 3y's. And then negative 3 times negative 6 would be positive 18. So that equals positive 18. The top equation we're just going to rewrite. So that was 6x plus 3y equals negative 17. Now you'll see in doing what we have done, in just choosing to eliminate the x's there, it's also going to eliminate the y's there as well. So let's just show it though. So we're going to add both equations together. It does eliminate the x's as we have planned. We have to add all the terms. 6x plus negative 6x zeroes out just as planned. But we see 3y plus negative 3y is 0y's. I need to see that because anything times 0 needs to be 0. But we see here that negative 17 plus 18 is 1. Well, I can't think of anything that I can multiply by 0 to get 1. I mean, there is actually, but I'm not going to, okay? So what we end up with here is there isn't anything that we can multiply, at least for now, by 0 in order to get 1. What this tells us then is that there actually is no solutions, which to me is a good thing because it takes away the need to do any more work right here. We actually are just pretty much done. So the other thing that this tells us, which hopefully may be helpful for you, is that since there are no solutions, it tells us that the equations created by the two, or I should rewrite that. The lines, if we were to graph these, the lines created from the two equations would be parallel and never, I'll emphasize that, never intersect. So in other words, these two lines, they have a lot in common, the slopes, but they never meet, which is kind of tragic. All other lines, though, they will meet once and then drift apart forever, which is also kind of tragic. What the heck? Little nerd joke in there for you guys. But no solutions is really what we're looking for in this one, and that completes this problem. So what you're looking for no solutions is if you ever choose to eliminate, you'll see that you get like 0y equals not 0. Like we saw in the example two examples ago, if you get 0y equals 0, that's always true. But anything times 0, if it equals not 0, it's automatically no solutions.